So we're solving November 2014, paper 23. Okay. There. All right. Question number 1. Successive ionization energies for fluorine, bromine, fluorine and for the group 17 elements. Fluorine, chlorine, and bromine are shown on the graph. Explain why the first ionization energies decrease down the group. Why do they decrease down the group? So yeah, so the number of shells increases, right? Hence, distance of outer electrons and shielding, which is repulsion from inner electrons, okay, from the nucleus, increase. Therefore, attraction decreases, right? Therefore, attraction decreases. Attraction of outer electrons towards the nucleus. Okay. Explain why there is an increase in the successive ionization energies of fluorine. So fluorine की पहली ionization energy सबसे कम क्यों है? दूसरी ज़्यादा क्यों है? तीसरी ज़्यादा क्यों? यहाँ पे fluorine. Greater attraction per electron, right? Essentially. So what happens is that what you have is, so the number of electrons decreases, hence the attraction per electron increases, right? So there are now more protons than neutrons, right? More protons than electrons as for successive ionization energies. Okay. And another thing that you should understand is that we're trying to remove an electron from an already positive ion. So obviously, usme bhi aapka, right? The cation charge also increases. So that's the idea. So I mean, this should come first. The cation charge increases because the number of electron decreases. I'll write it down here. Cation charge increases and number of electron decreases because number of electrons decreases. Its attraction per electron increases. Yeah. Next one. Group 7 is the only group in the periodic table containing elements in all 3 states of matter at room temperature. State and explain in terms of intermolecular forces the trend in boiling points of elements down the group. So first look at the keywords, right? State and explain. So what's the trend down the group? Group 17 का decrease करते हैं. Increase बोला ना. मुझे लगा decrease बोला मैंने. The boiling point increases down the group. Why? Van der Waals, induced dipole forces, yes. That's just a type of van der Waals force. So boiling point increases down the group, right? Now what happens is that in terms of intermolecular forces, so we say as the number of electrons increases, right, in a molecule down the group, the van der Waals forces due to the strength of van der Waals forces. Oh, whoa. Bhai, I swear the struggle, yeah. The strength of the van der Waals forces due to induced or temporary dipoles increases. Yeah. So you would say due to induced dipoles increases, hence more energy is needed, right, to overcome them. Yeah. Such a stupid question, I swear. एक ही ये 2 मार्क का भी आते, 3 मार्क का भी आता, 4 मार्क का भी, समझ नहीं आती यार, मतलब बस हाँ लंबी करनी है बेसिकली। वो नहीं होता जो इंग्लिश में सिखा देते लिटरेचर में, जितना लिखोगे उतने मार्क मिलेंगे। इस्लामियात में नहीं सीखा है आपने। हाँ यही बेसिकली 14 पॉइंट लिख के आ जाओ, वो हिस्ट्री में था। ओके हाँ, so interhalogen compounds are compounds that have different halogen compounds. One of them is which has fluorine and iodine by the following composition and mass. Calculate the molecular formula of this interhalogen compound. So, I mean, guys, everyone should know this. भाई आपको mass ratios दिए हुए हैं. Fluorine and iodine का mass ratio क्या है? Let's say in grams, whatever units, but in grams is easy. Okay, for every 42.8 grams of fluorine, you have 57.2 grams of iodine. So in terms of their molar ratios, the number of moles is just mass over molar mass, right? So fluorine के कितने moles होंगे? 42.8 divided by what's the molar mass of fluorine atoms? ये रहा आपका periodic table. Fluorine का mass होता है 19, okay? और iodine का होता है 126.9 atom का. So atomic mass of fluorine is 19 and iodine is 57.2 divided by 126.9. So what does the mole ratio come out to? 2.252. Yeah. 0.4514 for iodine. So we get the ratio. So we get the ratio I is to F is 2.252 to 0.451. So if you divide by the smallest number, right, you get 5:1. That's your ratio. So that means your compound is IF. Oh, sorry, I beta लिख दिया ना? नहीं, ये F है, ये I है. Okay. So what you get is IF5. Okay. F5I लिख दो, I5F लिख दो, यार, doesn't matter. OH2 is the same as saying H2O. They're the same thing. Usually by convention, the more electronegative compound element is written later, which is why like you'll always see H2O, but then NH3 में उल्टा होता है. So never mind, scratch it. उनको खुद ही नहीं पता क्या करना. Another interhalogen compound has the formula ICl. Draw a dot and cross diagram of a molecule of this compound showing outer shell electrons only. Explain whether or not you would expect this molecule to be polar. Okay. I के अंदर we have 7 outer electrons, right? So that let's just do it a simple way, ना? I में क्या है? Let's say dot I के, तो I के 7 हैं, right? Outer electron दोनों group 17 में, और chlorine के भी 7 हैं. That's the dot and cross diagram for this. Okay, and would this molecule be polar or not? Yes, and explain why. Yes, because chlorine is more, basically the electronegativities are different. That's the idea. And you have a polar molecule because chlorine is more electronegative than, or you can say because the electronegativities are different. Okay. Some reactions involving chlorine and its compounds are shown in the reaction scheme. Give the formulae of W, X, Y, and C. Okay, W. Cooled NaOH के साथ chlorine क्या बनाता है? This is a special type of redox reaction. That's a hint. Portionation. So with cold NaOH, we make NaCl and NaClO. Sodium chlorate 1. That's the name of this compound. Okay. Hot NaOH के साथ क्या बनाता है? Hot NaClO3. So यहाँ पर this is sodium chlorate 5. Right? So X is sodium chlorate 5. Hydrogen and chlorine क्या बनाएंगे? HCl. Yeah. We've done this reaction in group 17 theory. So we'll make HCl gas, hydrogen chloride. Right? You have to give the formula. So, and the last one. Okay. हाँ, HCl को हमने पहले पानी में डाला तो क्या बनेगा? हाइड्रोक्लोरिक एसिड. और फिर हाइड्रोक्लोरिक एसिड में क्लोराइड आयंस हैं. सिल्वर नाइट्रेट के साथ क्या प्रेसिपिटेट बनाएंगे? Silver chloride, right? So we have HCl and then we have AgCl solid. I'm trying to solve some more structure and isomers questions first, and then we'll don't worry. मैं जो भी papers देख रहा हूँ मैं देख रहा हूँ topics भी कौन सी cover हो रही हैं. So I'm trying to cover all the topics across the board. No? Okay. Write an equation for the reaction of chlorine with hot NaOH aqueous. Now we know that chlorine reacts with NaOH aqueous hot over here to form what? NaCl, NaClO3 and H2O. Okay. Now over here, if you remember, you should know you get 1 mark for just writing the species correctly and 1 mark for balancing it here. And if you remember, chlorine is oxidized by +5 from 0 to +5. So that means we need 5 of these guys to go down by -1. 5 -1 से बढ़ेंगे और 1 +1 से 1 +5 से बढ़ेगा. Right? The oxidation numbers balance out. If you guys don't remember, if you guys don't memorize it, you can always balance the equation. Okay. Then we have 3Cl2 and then we have 6 sodiums and then hydrogen kitne? 6, so 3H2O. Okay. So that's your balanced equation. State the oxidation numbers of chlorine at the start and at the end of the reaction in part 2. So at the start, it's just 0, right? That's in Cl2. Yes, and at the end, you have Cl minus में you have chlorine is -1, and sorry, parentheses -1. That's for NaCl and +5, right? That's for ClO3 minus and chlorate 5. Write an ionic equation for the reaction of Y with AgNO3. Ionic equation के अंदर nitrate and H plus ions the same रहेंगे, right? Nitrate और H plus ions को कुछ नहीं हो रहा. They're in solution. So only what's precipitating out, which is silver and Ag plus aqueous plus Cl minus aqueous form AgCl solid. Question 2. I'll give you guys a second to write this down if you need. Time नहीं होता. It's hard to complete. relative. अब सवा घंटे का कर लिया ना इस साथ. The Haber process for the manufacture of ammonia was originally devised at the end of the 20th century, at the start of the 20th century, and was developed into a full-scale industrial process by Karl Bosch in 1913. Why do they have to tell me this? Like, it doesn't help me with the question at all. Like, thanks for the history. I mean, I guess, but like, the key step in the process is this reversible reaction, right, to form ammonia. The hydrogen for this reaction can be formed. This is done in the presence of an iron catalyst. We write that down. The hydrogen for this reaction can be formed by reacting methane with steam, during which carbon monoxide is also produced. Write an equation for this reaction. बस इन्होंने हमको बता दिया ना क्या क्या हो रहा है. इन्होंने बोला कि हम लोग क्या करते हैं, we react methane with steam. We react methane with steam to form what? Carbon monoxide and hydrogen gas. They told us that in the question, right? So then we have to balance this equation, guys. H2 बस 3 हो जाएंगे ना. ये balance. हाँ? कुछ भी नहीं बोला, नहीं सर, ये बैलेंस कर, मतलब आपको फेंक रहे हैं, मतलब हाँ हाँ, यस, लेना याद करना, फेंक रहा. यूज द बोर्ड. Okay, use the Boltzmann distribution shown to explain why a catalyst increases the rate of this reaction. You have to show it. So what should I label on this graph to show how a catalyst increases the rate of a reaction? Yes, so let's say before catalyst was somewhere here. Okay, this is, let's say, the activation energy without the catalyst. Okay. And basically the activation energy with the catalyst will be lower, right? So we can say that this over here is the activation energy with a catalyst. That's all literally what you have to do to label it, to show what's happening. Okay. To explain why a catalyst increases the rate of reaction. All right. Now, what that means is, if you guys remember, what that means is that initially only this many molecules were reacting, the area under the graph. Now we have that plus this guy. So the total number of molecules reacting has increased, right? And what's the explanation? So we can say that a catalyst, what does it do? Yes, catalyst lowers the activation energy by providing an alternative pathway. Okay. Or rather, we should say that a catalyst increases the rate of the reaction by providing an alternative pathway with lower activation. Catalyst increases the rate of a reaction by providing an alternative pathway with lower activation energy. Yes, now because it's 4 marks, you guys should expand on this a bit. Okay, you will also say lower activation energy, which means that there are now more molecules that have energy greater than the activation energy, right? So we can say that there's a no, the portion of so there's a greater number of successful collisions, right? Because more molecules have energy equal to or higher to the activation energy. That's it. That's your 4 marks right there. Huh? Product किसमें ज़्यादा? Rate बढ़ रही है ना? Product थोड़ी yield नहीं बढ़ रही भाई. अगर आपने 10 मॉलिक्यूल बनानी है, दोनों जगह में 10 बनेंगी, लेकिन वो 5 मिनट में बन जाएंगे, अब 2 मिनट में बन जाएंगे, वो बात है. So it'll just happen faster. Okay. The three-dimensional diagram to show the shape of an ammonia molecule. Name the shape and state the bond angle. Everyone should know this. Bio-wali theory, effective collisions. Yeah, successful collisions. Yes, Roha, that's precisely it over here. Okay. Similar to enzymes. Enzymes are catalysts. It's the same explanation. Draw a three-dimensional diagram to show the shape of an ammonia molecule. What's the shape of an ammonia molecule? Ammonia has a lone pair and it has 3 bonds. So the hybridization is sp3 and the bond angle is 107 degrees. The shape is called trigonal pyramidal and the bond angle is 107 degrees. The Haber process is typically carried out at a temperature of 400 degrees Celsius. With reference to Le Chatelier's principle and reaction kinetics, state and explain one advantage and one disadvantage of a higher temperature. Okay, so what's the advantage of using a higher temperature? More rate is higher, right? So we can say that, so basically the advantage that we have is, you can write it like this. The advantage that we have is at higher temperature, right? There is a greater frequency of, or a greater chance of successful collision. So hence the rate increases. Since the particles have more energy. Okay. So I mean, if you wanted to, like, honestly, the simple way to answer this would be something like this. You just say the advantage is that that the rate increases. And then why? Because at higher temperatures, there's a greater chance of successful collision. So 1 mark is just for the increased rate, and 1 mark is for the explanation. Okay. What's the disadvantage? Yes, because it's an exothermic reaction, remember? The backward reaction is when you're providing excess heat, right? The backward reaction is endothermic, so it'll want to take up that heat, right? It'll want to take up that heat. In other words, the backward reaction will be favored, so you'll have a lower yield. So the disadvantage that you have is, you have a lower yield. Okay, and the reason for that is because the reaction is exothermic. Okay, hence an increase in temperature favors the backward reaction, so the yield decreases, right? State the expression for the equilibrium constant Kp for the formation of ammonia from nitrogen and hydrogen in the Haber process. Kp is in terms of partial pressures, right? So Kp में हमारे पास क्या होता है? We have the partial pressure of ammonia squared and then yes, so we have the partial pressure of, not the moles, the partial pressure of ammonia squared, okay, divided by the partial pressure of hydrogen cube times the partial pressure of nitrogen. Okay, so that's your expression. 2 moles of nitrogen and hydrogen were put in a vessel and left to reach equilibrium. At equilibrium, the pressure was 2 times 10 to the power of 7 pascals, and the mixture contained 1.6 moles of ammonia. Calculate Kp and its units. Yes, exactly. So we have NHN2 plus 3H2 gives me 2NH3. This is your equilibrium reaction, right? And what we have is initial change and at equilibrium. Initially, we had 2 moles of nitrogen. This is number of moles right now. Okay. Initially, I had 2 moles of nitrogen and 3 moles of hydrogen. And obviously, we started with 0 moles of ammonia. At equilibrium, we had 1.60 of ammonia. So that means ammonia increased by 1.60. So then what happened to hydrogen? Or what happened to nitrogen first, let's say? अगर इसके 1.6 से बढ़े तो नाइट्रोजन के कितने रिएक्ट करे होंगे 0.8 because 1:2 ratio. So इसके 0.8 ने रिएक्ट किया, सही है. और हाइड्रोजन के कितने ने रिएक्ट किया होगा 2.4, 3 times as many, right? So that was the change. So at equilibrium, nitrogen कितना रह गया 1.2 or 60. There we go. So these are your equilibrium number of. Over here we can say that the mole fraction, okay, mole fraction for each of these is, what's the total number of moles here? 3.4, right? So we have 1.2 over 3.4, that's the mole fraction, times the total pressure, which is 2 times 10 to the power of 7. So that's the partial pressure of nitrogen. Sorry. That's the partial pressure of nitrogen. 8.16 into 10 to the power. How? Should be lesser than the total pressure. अबे ज्यादा कैसे हो सकता है टोटल प्रेशर से? पार्शियल प्रेशर. क्या आ रहा है? सबके अलग अलग आ रहे हैं. 7 into 10 to the power of 6. 7.06 ये रोहान ने जो भेजा है. 7.06. Okay, so 7.059 just to be more precise. So here the partial pressure is the mole fraction, that's the moles of nitrogen divided by the total number of moles, which is not 3.4. Wait, 3.4 here. The moles of nitrogen divided by the total number of moles times the total pressure. So इसका क्या आता है 7.059 times 10 to the power of 6 pascals. Okay. Next wala 0.6 divided by 3.4 into 10 into 2 into 10 to the power of 7. क्या है 3.529 into 10 to the power of 6 pascals, right? और आखिरी वाले का क्या है 1.6 divided by 3.4 times 9.412 into 10 to the power of 6. Okay, so these are your partial pressures. Now you will calculate the Kp ki value. So the Kp ki value will be, Kp was ammonia squared, so 9.412 into 10 to the power of 6 squared divided by 3.529 into 10 to the power of 6 cubed for hydrogen and 7.059 times 10 to the power of 6 for nitrogen. That should be 0.855, okay, 2.86. Into 10 to the power of what? क्या आ रहा है? Units क्या आ रही हैं? -13. And what will the units be? Pascal squared over Pascal to the power of 4. नहीं, Pascal -2. Pascal squared divided by Pascal to the 4. जो units दी नहीं है वही units लिखोगे ना. It doesn't matter atmosphere हो के pascals. इस particular question में क्या use किया हमने throughout? Pascals. So this will be pascals to the power of -2. So the Kp is 2.86 times 10 to the power of -13. And the units are pascals. 1/Pascal squared. Okay. But ये देखो ना ice table तो काफी straightforward है. हाँ. Yeah. This one. P, Q, R, and S are structural isomers with the molecular formula C5H10. They all decolorize bromine in the dark. So they're all what? Alkenes. P, R, and S do not exhibit stereoisomerism, but Q exists as a pair of cis-trans isomers. ये हमने क्या था last year, yes. All four compounds react with hot concentrated potassium manganate to produce a variety of products shown. T reacts with 2,4-DNPH to form an orange crystalline product, but does not react with Felling's reagent. Give the formula of P, Q, R, S, and T. Okay. So what is P over here? Now what we're doing is potassium manganate से क्या होता है alkene को? Strong oxidation, right? Double bond टूट जाता है. और कार्बन डाइऑक्साइड कम बनता है जब उस डबल बॉन्ड वाले कार्बन पे क्या लगा होता है? ये डबल बॉन्ड टूटा ना, तो ये कार्बन डाइऑक्साइड तब बनता है जब इस डबल बॉन्ड पे एक तो CH2 लगा होता है और दूसरी चीज क्या बननी है यहाँ पर है स्ट्रेट चेन 4 कार्बन एसिड. That means that it must be a CH, right? CH2CH and then just a 4 carbon acid बन रही है, right? So we just have a straight chain CH2 CH2 CO2 क्या कह रहा हूँ CH3 CH3 CH3. Okay, so what happens here is that when I break this double bond, the CH2 becomes carbon dioxide and this CH over here becomes the carboxyl group. I'll highlight it. Okay. All right. Next one, Q. Oh, all right, next one, Q. अब Q में क्या बन रहा है? एसिड बन रही है एक तरफ और दूसरी तरफ भी एसिड बन रही है. तो दोनों तरफ CH है, तो Q में we have a CH bonded to a CH, right? Single carbon, so that's CH3. और दूसरी तरफ CH2 CH3. So that's your 5 carbon compound. T R है ना, T बताया हुआ है ना हमें. अच्छा R में देखें, R में क्या होता है? R में तो CO2 बन रहा है एक तरफ और दूसरी तरफ H2O है. तो दूसरी तरफ एक तरफ तो CH2 है ना R में, ये तो समझ आ गई, राइट? एक तो CH2. अब दूसरा क्या है? अब वो बता रहे हैं कि जो T बना है, T reacts with 2,4-DNPH but not with Fellings. So what is T? It's a ketone. 2,4-DNPH is for aldehydes and ketones, and Fellings is only for aldehydes. If it doesn't react, then it must be a ketone. Okay. अब 4 कार्बन कीटोन में हमारे पास एक ही पॉसिबिलिटी होती है, right? Which is this guy. This is our possibility for the ketone. Agreed? Okay. Now, what that means is that this CH2 was bonded to a carbon that had a CH3 and it had a CH2 CH3, because ये जो डबल बॉन्ड O है ये कहाँ से आया? ये डबल बॉन्ड O तब आया था जब हमने डबल बॉन्ड तोड़ा था. तो कार्बन पहले से किस चीज से बॉन्डेड था? एक कार्बन से और इस कार्बन. So exactly, so what we had was we had a CH3 and we had a CH2 CH3 on this carbon over here. That makes sense to everyone? Huh? क्यों? ये कार्बन डबल बॉन्ड बना रहा है ना, एक बॉन्ड इस कार्बन से बना लिया, एक बॉन्ड इस दूसरे कार्बन से बना लिया, टोटल 4 बॉन्ड हो गए, राइट? लेफ्ट वाला कौन सा? ये कार्बन जो है इसने दो बॉन्ड इस कार्बन के साथ बनाए हुए, एक बॉन्ड इस कार्बन के साथ और एक बॉन्ड इस कार्बन के साथ, राइट? So and what's the structural formula of T? T is just 4 carbon ketones. So CH3CO, CH2, CH3, right? And last one is S. अब S के अंदर क्या मिल रहा है? S के अंदर again you have a CH because you're getting an acid. So it's a 2 carbon acid. So you have a CH3CH, right? That's this guy over here. And then the other guy is a ketone, CH3 twice. That means the other carbon atom is bonded to two CH3s. It's just this. That's your ketone, right? So that's where the double bond was. Okay. कौन सा वाला? S, T, T. अबे T तो वो की, अबे T तो बना है हमने जब R को ऑक्सीडाइज किया, R समझ आ गई? तो R कहाँ से आया था? हमको पता है कि T क्या है? T is a ketone, right? It reacts with 2,4-DNPH and not with phenylings. So it's a ketone. 2,4-DNPH के साथ aldehydes और ketones react करते हैं, phenylings के साथ सिर्फ aldehydes करते हैं. इसका मतलब ketone होगा. अब अगर कीटोन है और 4 कार्बन कीटोन है, उसमें सिर्फ एक पॉसिबिलिटी, 4 कार्बन कीटोन में सिर्फ यही होता है और कोई पॉसिबल कीटोन नहीं है. सो द स्ट्रक्चरल फॉर्मूला हैज टू बी दिस, बिकॉज़ मिडिल वाले कार्बन पे डबल बॉन्ड होगा. इस वाले पे हो कि इस वाले पे हो, इट्स द सेम थिंग. ऑलराइट, explain what is meant by the term stereoisomerism. Molecules which have the same molecular, obviously, but also the same structural formula, okay, but different arrangement of atoms in space. Okay. All right, next one. Draw the displayed formula of the geometrical isomers of Q and name them both. Okay, so Q, we just saw this guy. This is Q. I'll just copy paste this guy over there. Okay, so this is what we had for Q. There was a carbon double bond bonded to a hydrogen, right? And then we had a CH3 and a CH2, CH3. So we have a CH3. Okay, you can draw it like this. I just don't like the way it looks, so I'm just going to draw it the way I like it, like this. Huh? Displayed में सारे bonds दिखाने पड़ेंगे. Yes. So carbon is bonded to a CH3 and it's bonded to a CH2, CH3. ये तो गलत है. CH2, CH3. Nice. This is cis. Okay, good. Cis. कितने कार्बन्स हैं? चेन 1 2 3 4 5. Cis, pent, 2ene. Okay, and the other one is obviously going to be the trans isomer. Okay, so here we have the CH2, CH3, H, CH3. बहुत सारी है यार ये. So we gotta do रोजी हलाल करनी है. यहाँ पर CH3 आ गया और यहाँ पर H आ गया. And this is trans. ये तो मतलब ये तो इन्होंने जुल्म किया ना. इसका क्यों डिस्प्ले बनवा रहे हैं? मतलब कोई मतलब ऐसा कोई दे देते जिसमें मतलब तमीज से बंदा बना दे. ट्रांस. फिर मेरी बात है किस बात पे सड़ी कि अगर किसी ने एक हाइड्रोजन या कुछ गलती से मिस कर लिया ना इसमें, who know, भरोसा है, एतमाद है आप, मुझे तो नहीं. हाँ तो फिर ट्रांसपेंट 2. यस, Name the organic product. Okay, so name the organic product of the reaction of T with sodium borohydride. T जो है हमारे पास था ब्यूटानोन 4 कार्बन कीटोन. NaBH4 के साथ क्या रिएक्शन होगा? NaBH4 क्या होता है? किसी को याद है? रिड्यूसिंग एजेंट. और कीटोन्स को रिड्यूस करते तो क्या बनता है? अच्छा, क्या चीज ऑक्सीडाइज होकर कीटोन बनाती है? किस तरह के अल्कोहल? सेकेंडरी. टर्शियरी तो ऑक्सीडाइज ही नहीं होती ना. सेकेंडरी. प्राइमरी से एल्डिहाइड या एसिड बनता है, सेकेंडरी से कीटोन बनता है. सो वी हैव अ 4 कार्बन सेकेंडरी अल्कोहल, स्ट्रेट चेन अल्कोहल, राइट. सेकंड कार्बन पे क्या आ जाएगा? OH ग्रुप होगा जब रिड्यूस करेंगे. सो दैट विल बी ब्यूटन, ब्यूटन 2 ऑल, राइट. ब्यूटानोन को रिड्यूस करेंगे तो ब्यूटन 2 ऑल बनेगा. So this is secondary alcohol. All right, last one, last question. A series of reactions based on propan-1-ol is shown. In the first reaction, propan-1-ol is is dehydrated to form an alkene. Yes, elimination. So what's the reagent that we use for this? We can use concentrated sulfuric acid. We can also use Al2O3, if you guys remember, and heat. Right? So we have concentrated sulfuric acid and heat. Write an equation for the reaction 2 using O to represent the oxidizing agent. In the second reaction, the alcohol is converted into a carboxylic acid. इसके अंदर क्या होता था? You guys remember? It's CH3, CH2, CH2OH reacting with oxygen. अच्छा, carboxylic acid बनाने के लिए you're going to need 2 oxygens. एक ऑक्सीजन से एल्डिहाइड बनेगा, दूसरे ऑक्सीजन से कार्बोक्सिलिक एसिड. व्हाई? यहाँ पर एक ऑक्सीजन बढ़ गया और 2 हाइड्रोजन कम हो गए, यानी कि जो दूसरा ऑक्सीजन है वो 2 हाइड्रोजन को अपने साथ ले जाता है. सो व्हाट वी मेक इज दिस. This is what we end up making. CH3, CH2, CO2H. That's where one oxygen goes, and the other oxygen goes with the 2 hydrogens that left the alcohol. Okay. Suitable reagent and conditions for this. ये तो सबको पता होगा. Acidified dichromate or acidified manganate and heat under reflux, right? If you distill the product, what would you make with dichromate? Aldehyde, right? Aldehyde. Alcohol को oxidize करते हैं तो पहले aldehyde बनाते हैं, फिर acid. Heat under reflux means heat to completion. Heat and distill means जैसे aldehyde बने, it has a lower boiling point, you can distill it off. But here, because we're making the acid, we just heat under reflux. Give the structural formulae of U and V. Okay. U में क्या हो रहा है कि एल्कीन बन रही है, स्टीम के साथ रिएक्ट करिए तो क्या बनेगा? हाँ, तो क्या एल्कीन स्टीम के साथ एल्कीन बनाएगा, अल्कोहल बनाएगा ना, H2O ऐड होगा ना मेरे भाई. अब लेकिन अब यहां पर बस एक चीज का ध्यान रखना, OH कहां पर जाएगा? बीच वाले कार्बन पे, याद है? सेकेंडरी कार्बोकैटायन. पहले हाइड्रोजन लगेगा, हाइड्रोजन लाइक्स टू गो वेयर देयर इज ऑलरेडी मोर हाइड्रोजन्स प्रेजेंट, एंड देन द न्यूक्लियोफाइल व्हिच इज, जैसे HBr जब ऐड करते थे मिसाल के तौर पे, इफ यू गाइस रिमेंबर, HBr के साथ क्या होता था? हाइड्रोजन यहाँ लगता था और Br माइनस सेकेंडरी कार्बोकैटायन को प्रेफर करेगा. सेम थिंग विद अल्कोहल्स. So the structural formula for U would be that the OH would go here in the middle carbon and the H would go at the end. So what? Major product. Whenever they say give the structural formula, always give the major product. Unless they ask for major and minor separately, हमेशा major product देना, सही है? In some cases they might give you a mark, but it's always better to stick to that. Okay, yes. So we have CHOH and then CH3. Okay, that's U. What about V? When the secondary alcohol here, propan-2-ol, is reacting with HBr, concentrated HBr के साथ क्या बनाता है alcohol? It's just a nucleophilic substitution reaction. The OH is replaced by bromine. Okay. In this case, they'll probably accept both answers, but I'll always go with the major. In some cases, they won't. In some cases, they'll only accept the major. In some cases, they might accept both. So it's just better. Like major, हमेशा correct होगा. Okay. Suggest a suitable reagent and condition for reaction 3. And reaction 3, that halogenoalkane is converted back into an alkene. Elimination of halogenoalkanes mein, what is the reagent and condition? Last paper में भी क्या था ये? NaOH in ethanol and heat under reflux.